On the morning of June 30th, 1908, something exploded over the Tunguska River in Siberia, with a force equivalent to roughly 1,000 Hiroshima bombs. No one has ever found a crater. 80 million trees were flattened across an area of more than 2,000 square kilometers, all of them pointing outward from a single center like spokes on a wheel. For more than a century, scientists have searched that same patch of forest for fragments of whatever caused it, and the search has never produced a conclusive answer. What follows is a count of 11 documented facts about that morning, building toward the detail that still unsettles the researchers who study it most closely. The date itself is the first fact worth sitting with. At around 7:17 in the morning, local time, witnesses across a stretch of central Siberia reported a fireball brighter than the sun crossing the sky, followed by a shockwave that knocked people off their feet at distances of 60 kilometers or more. Barometers in England registered the pressure wave. Seismic stations as far away as Germany picked up the ground tremor. This was not a local event contained to one river valley. It was a planetary-scale release of energy, and it happened in a place with almost no people to witness it up close. That last detail matters more than it first appears. The Podkamennaya Tunguska region was, and still is, one of the most sparsely populated areas on Earth, home to small groups of Evenki reindeer herders. Their accounts, collected only years later, describe tents thrown into the air and reindeer killed in the initial blast. Had this same explosion occurred over a city the size of London or St. Petersburg, the death toll would likely have run into the millions. That single fact, that the deadliest impact event in recorded history happened to hit almost nobody, is the first thing that should unsettle you, and it is far from the strangest thing on this list. Here's what we actually know about the scale of the destruction. Soviet expeditions beginning in the 1920s, led by mineralogist Leonid Kulik, mapped a fall zone of flattened trees covering approximately 2,150 square kilometers, an area larger than the city of London. Kulik expected to find a crater and a mass of iron meteorite fragments, the way earlier impact sites like Arizona's meteor crater had produced. He found neither. What he found instead was a forest where every tree beyond a certain radius had been snapped at the base and laid outward, while trees directly beneath the blast center were left standing, stripped of branches, like telephone poles. That detail, trees standing upright directly under the epicenter while trees farther out were flattened, is the signature that later convinced scientists this was not a ground impact at all. A meteorite striking the Earth would carve a crater and throw debris in a pattern radiating from that crater's center. What Kulik had mapped instead matched the pattern of an airburst, an explosion that occurred kilometers above the ground, sending a shockwave downward and outward in a cone, flattening trees at the edges of that cone while leaving the trees directly underneath relatively undisturbed. This is where most explanations of the 20th century quietly ran into trouble. If it was an explosion in the air rather than an impact on the ground, the object causing it would have needed to release its energy before ever reaching the surface. Researchers have estimated the responsible body was a stony asteroid or a fragment of a comet, somewhere between 50 and 60 meters across, traveling at cosmic velocity, perhaps 15 to 20 kilometers per second. At that speed and density, atmospheric pressure alone can be enough to shatter such an object several kilometers above ground, releasing its kinetic energy all at once in a single catastrophic burst. No crater required, because nothing solid ever reached the dirt. That's a clean explanation, and it's the one most textbooks now repeat. But here's the detail that doesn't fit quite as neatly as the summary suggests. Decades of expeditions to the Tunguska site, including Soviet surveys through the 1950s, 60s, and 70s, have never recovered a confirmed meteorite fragment from the event. Small metallic and glassy spherules have been found in soil samples from the region, and some researchers have linked their composition to a stony asteroid impact. But no one has produced the kind of unambiguous large fragment that would close the case the way iron chunks did at Arizona's meteor crater. If you're inclined to ask why an explosion powerful enough to flatten a city left behind so little physical trace, you're asking the same question researchers have been arguing about for 100 years. And it's a fair one to bring up in the comments, because there is genuinely no consensus answer. This is a good place to pause on why this kind of event still matters today. If the scale and mystery of places like this are the kind of thing you find yourself drawn to, subscribing means you won't miss the next one we dig into. Because the Tunguska event isn't simply a historical curiosity, it is treated by contemporary planetary defense researchers, including teams associated with NASA and the European Space Agency, as a live scenario. An object the size of the one believed responsible for Tunguska is genuinely difficult to detect with current sky survey technology until it is very close to Earth, and an airburst of that scale over a modern city remains, by their own estimates, a plausible, if statistically rare event. Officially, the explanation is the asteroid airburst hypothesis, and it remains the leading scientific consensus. The problem is that several alternative explanations were floated over the decades specifically because the fragment evidence was so thin. And while most have since been ruled out, the fact that they were taken seriously at all says something about how incomplete the picture still is. Some early Soviet researchers, including engineer Alexander Kazantsev in the late 1940s, proposed a nuclear explosion, an idea taken seriously enough that later expeditions specifically tested the soil and tree resin for radiation. Those tests found some anomalies in growth patterns and isotope ratios in the years following the blast, but no confirmed elevated radiation consistent with a nuclear detonation, and the hypothesis was set aside for lack of supporting physical evidence. Other proposals over the years included a comet composed largely of ice, which would explain the absence of solid meteorite fragments, since the object could have simply vaporized far more completely than a stony asteroid. This idea has genuine scientific backers and is not fringe, though it has struggled against evidence from atmospheric modeling suggesting a stony, rocky composition is a better fit for the blast's altitude and energy profile. Researchers have not fully settled which composition, stone or ice, best explains the entry, and that disagreement between credentialed scientists, not internet speculation, is itself one of the more interesting undercurrents of this story. There's one detail researchers keep coming back to that deserves its own mention. Sediment cores taken from Lake Cheko, a small lake roughly 8 kilometers from the epicenter, were studied by an Italian research team in the early 2000s, who proposed the lake itself might be an impact crater formed by a surviving fragment of the object, filled in over the following century. This theory generated real debate. Later studies using ground-penetrating radar and sediment dating suggested the lake likely predates the 1908 event by centuries, which would rule out an impact origin. But the dating methods themselves have been disputed enough that the question has not fully closed either way. That's the kind of loose thread that never gets a tidy resolution in most documentaries, but it's worth admitting outright. No one has definitively settled what Lake Cheko is or is not. That should have settled the broader question of whether any solid trace of the object survived. It didn't. What the data doesn't explain, even after 4 generations of expeditions with modern instruments, is why an object powerful enough to level a forest the size of a major metropolitan area left behind evidence this ambiguous. Compare it to the Chelyabinsk meteor event of 2013, also over Russia, where a much smaller object exploded in the atmosphere and left behind fragments that were recovered, analyzed, and displayed in museums within months. Tunguska, more than 100 years later and orders of magnitude more powerful, has never produced that same level of closure. How an event that large can remain this physically elusive has never been fully demonstrated by any single research team, and it remains one of the genuinely open questions in this field. No one disputes the first part of this story, that something exploded over Siberia in 1908 with the force of a large hydrogen bomb, and that 80 million trees fell as a direct result. It's the second part that causes the argument. What, precisely, that something was, and why it left so little of itself behind. The asteroid airburst hypothesis remains the best supported explanation available, backed by atmospheric modeling, the radial treefall pattern, and the discovery of related spherules in the soil. What remains genuinely unresolved is the exact composition, the precise size, and the reason physical fragments have proven so difficult to confirm across more than a century of dedicated searching. Return to that image from the opening. Trees still standing directly beneath the blast, stripped bare, surrounded by a forest of fallen giants pointing away in every direction. That picture is the closest thing to physical testimony this event left behind, and it is still, after all this time, more eloquent than any fragment anyone has managed to dig out of that soil. Planetary defense researchers today use Tunguska as their working model for what an undetected asteroid could still do to a modern city, precisely because an object of that size remains hard to spot with current early warning systems until it is dangerously close. The next object like it may not choose an empty stretch of Siberian forest to land on. Whether we would see it coming in time is a question no one has yet had to answer for real.